Hey guys, so here's the notes for 5.2 day 2. We're going to be talking about multiplicity and then also graphing when we are in factored form. So what's multiplicity? It's the number of times a zero's factor appears in the polynomial. So for instance, when we have x plus 4 times x minus 2, notice that has zeros of x equals negative 4. Remember, to get zeros, we just set the factors equal to 0. So I have x plus 4 equal to 0, so I get x equals negative 4. And I do the same thing with my 2. I do x minus 2 equals 0 and x equals 2. So that's how I get those zeros, each with a multiplicity of 1. Now you might be wondering, well, how do we know? Well, since the exponent on each factor is 1. So basically, to figure out the multiplicity, you look at the exponents on each factor. So like on our next one, once again, we have the zeros of negative 4 and 2. But notice that negative 4 has a multiplicity of 3 because the exponent on the factor is 3. Okay? So you could say multiplicity is equal to the exponent on each factor. Okay, so now let's go ahead. We're just going to practice some of that. So here are some problems that we can have. So like on the first one, we have x plus 2 times x minus 1. Notice our zeros. Remember, to get these zeros, you set each factor equal to 0 and solve. So we have the zeros of negative 2 and 1. Notice that for each of these factors, the exponent is 1. So the multiplicity is 1. Let's try the next problem. Let's find the zeros. So remember, to find the zeros, we take our factor and set it equal to 0. So I get x equals negative 2. So that's one of them. And then I get x minus 1 equals 0. So I get x equals 1. Okay. But now let's look at the multiplicity. So for negative 2, notice what our exponent is. It is 2. So the multiplicity is 2. Okay, what about for the x minus 1? Well, the exponent is 1, so that means our multiplicity is 1. Okay, you'll notice that will be the same thing then on the x plus 2 times x minus 1 squared. So we have negative 2 and 1. And notice on the negative 2, the exponent or the factor has a exponent of 1, so that's a multiplicity. Same thing on x minus 1. Notice that the exponent is 2, so that's the multiplicity there. Okay, I would like you guys to go ahead and pause the video and find the zeros in multiplicity for the ones that are blank. Okay, let's see what you got. So I have x plus 2, we set that equal to 0, so I get x equals negative 2. Now notice what the exponent is on that. That is a 1, so that's the multiplicity as well. Okay. And then we have x minus 3, or x minus 1, excuse me, set that equal to 0. I get x equals 1. So that's my 0. Remember, other names for zeros means x-intercepts, roots, and solutions. And notice that my exponent on the factor of x minus 1 is 3. So that's my multiplicity. Okay, let's do the next one. Once again, we have x plus 2. Always set the factor equal to 0 and solve. So I get negative 2. Now, notice for this one, for our multiplicity, the exponent is 3. So that means our multiplicity is 3. I do the same thing with x minus 1, set it equal to 0. I get x equals 1. And so the multiplicity here, notice our exponent on that factor is 3. So our multiplicity is 3. Okay? Now, what happens then with our graph? Because we are going to be graphing some of this stuff. Now, one thing is to notice, right, the graphs of these functions. Not only does our exponents tell us the multiplicity, but it also tells us the degree of the function. So when we are in factored form, in order to find the degree of the function, we need to add up the exponents. So let's go ahead and write that down. So that's going to be very important to when we do problems like this, right? So to find the degree in factored form, add the exponents on the factors. this is really neat. So let's look at the first one. So notice that we have the factors of x plus 2 and x minus 1, and each of them has an exponent of 1. Well, to find the degree, we're going to add those exponents. So in this case, we get a degree of 2. Okay? Now let's look at the next one. So to find the degree here, notice that we have the exponents of 2 and 1, which gives us 3. And then our last one, same thing here. We're going to find the degree. Notice that we have 1 and 2 as our exponents. We get 3. Okay? So anytime we're in factored form, remember that means we have these parentheses. We add the exponents to get our degree. And then our a value, remember that's our leading coefficient, is always just going to be the number that is in front of our first set of parentheses. Now, once again, these in parentheses are what we call factors, and to solve to get our zeros, or other names, roots, x-intercepts, solutions, we set them equal to 0, and then the multiplicity comes from the exponents on the factors. Okay, so that's a lot. Make sure you have that down. Now, what happens when we do have all this information? Okay, well, think about when we have odd multiplicity. So that means we had our multiplicity was an odd number, like 1, or it could be 3, right? Multiplicity of 3. Well, what happens to our function? Well, at that x-intercept, or at that x value, what we're going to say, it basically crosses the function, okay? So I'm going to write that down here. So we have an odd multiplicity. The graph crosses at the x-intercept. Or crosses the x-axis. Okay, but what happens when we have an even multiplicity? So that means even numbers. Well, that means the graph, we're going to say bounces on the x-axis. And we have some examples here of when we have odd and even. So let's kind of look at here. Notice that for our x-intercepts of -2 and 1, the multiplicity is 1. 1 is an odd number. Notice that at both of those x-intercepts, our graph crosses the x-axis. Now notice on the next one, once again at our zeros of -2 and 1, at -2, our multiplicity is 2. 2 is an even number, so it bounces. And when we talk about bouncing, think about a bouncing ball, right? It hits something and comes right back down, okay? So either it can go up and come right back down, or you'll see in the other one, it goes down and comes right back up. Now, when we have a 0 of 1, our multiplicity is also 1, which is an odd number. That means we cross the x-axis. On this one, we have a 0 of -2, and our multiplicity is 1. 1's an odd number, so we cross the x-axis. Now, at 1, basically, we have a multiplicity of 2. 2's an even number, so we bounce. So here, we actually come down to the x-intercept and come right back up. Okay? So that's going to be very important when we have to sketch the graphs of these. Okay, so let's go ahead. We're going to do an example here. Okay, so which of the following graphs would represent the polynomial? Okay, notice we are in factored form. Okay, and notice we have 2 x-intercepts, or 2 zeros, because there are 2 factors. Okay. Now the thing is, let's talk about maybe the degree. Remember, since we're in factored form, to find the degree, we're going to add the exponents. So here, what we're going to do is take our 2 and our 3. Those are our exponents and add them. So the degree is going to be 5. Okay. Now notice 5 is an odd number. Okay. So it's going to be odd. That's when we think about, okay, which way do the arrows face? Okay. Now we also have to think about our A value, or the leading coefficient. So the leading coefficient is positive. So when we have an odd positive, which way do our arrows go? Well, for our in behavior, that means we're going to go down, up for an odd positive. Okay? So let's go ahead, let's do a process of elimination. A doesn't work. Okay? We do have a down, up, so B might work. C might work, so we have a down, up. And D might work, so we have a down, up. Okay. So A is the only one that doesn't work. Well, now let's have a look at our, basically what happens with our multiplicity here, okay? So at x equals b, the multiplicity is a 2. So that means we are going to balance. So we need a place where we balance. Then at x equals c, the multiplicity there is a 3. So we cross. So we need to look for, okay, where do we have 2 x-intercepts? And then we bounce and cross, okay? Well, B is a idea because we bounce here and we cross here, okay? But that's a little bit more of a flex, right? Okay, what about C? Well, C doesn't work because we only have 1 x-intercept. But what about D? Does D work a little bit better? Well, if we look, yes, we have a bounce and a cross. So D would be our answer here. Okay. Okay, make sure you watch the next part. That's where we're actually going to be graphing or sketching polynomial functions.